Today, I'm going to talk about PrivacyGo Data Clean Room, a new tool for data collaboration. At TikTok, we build products and features for our platform. We do so by keeping privacy in mind, building privacy in principles throughout the entire product development lifecycle. Here's an overview of today's talk. We are going to talk about the typical workflow of data collaboration, existing solutions, their pros and cons, and how our approach can address these challenges. Then, I will show you a demo of this framework. At last, I will present the project current status and the future roadmap. Let's talk about data collaboration first. Data collaboration framework allows multiple parties to collaborate on data. For example, a data provider may make their data available to data consumers so that data consumer can perform various data analysis. In such framework, the data platform allows the data provider to control policies on the data. The policy includes not only access permissions, but also various privacy policies, such as data retention. Also, the platform may provide the data consumer with tools to utilize the data, such as interactive query interface. As a generalization of data collaboration frameworks, multiple data providers and the consumer can get involved in the collaboration. For example, there might be more than one data provider providing different data sets. Each of the data provider can also be a data consumer at the same time. In such a multi-way setting, the platform needs to provide the user with tools to securely collaborate. There are two main issues of data collaboration: security and privacy. No matter what data they are sharing, the confidentiality and integrity of data and the computation needs to be protected. But it is not only a requirement when the data is privacy sensitive. For private data, we also need to think about how we enforce different privacy policies and control data lifecycle. For example, purpose limitation requires the data to be collected and processed only for specific purpose, with explicit consent from the individual. Also, data retention policy requires the data to persist only for a defined period of time. When designing a data collaboration framework, we want to achieve the following goals. First, usability. We want to provide an interactive tool to better utilize the data. Second, security. We want to provide confidentiality and the integrity of data in use and provide strong access control. Third, privacy. We want to make it possible to enforce privacy policies such as purpose limitation and data retention on the data. Then, accuracy. We want to provide accurate results on real data as well as an evidence of execution. Lastly, deployment. We want to make it easy to deploy to the cloud environment. Then, let's discuss about some existing solutions and their pros and cons. Firstly, SQL policy-based data clean rooms are very common, where a data platform is provided by a third party who does not have any conflict of interest with participants of the collaboration. Usually, these solutions require data provider to configure fine-grained SQL policies, such as who can run which query on which table. Secondly, differential privacy. Differential privacy is based on mathematical foundation to limit information leakage of certain dataset or queries. Basically, this solution will pre-process data and add noises to aggregated SQL results to limit information leakage. In addition, there are other solutions based on trusted execution environment. The idea is to use remote attestation to co-verify the code before releasing data, and rely on hardware-based isolated environment to protect data in use data. However, we found that none of the solutions meets all of our requirements of data collaboration. While policy-based data clean room provides great usability and accuracy, it is very hard to protect private data or to enforce data policy. Differential privacy provides great usability. However, it needs to sacrifice accuracy. At last, trusted execution environment, on the other hand, seems to be a good solution, but its attestation mechanism is not really usable for interactive interface such as dynamic data querying or programming. With these observations, we designed a two-stage data clean room that combines different privacy-enhancing technologies such as differential privacy and trusted execution environments to balance usability, accuracy, security, and privacy. The main idea is that the data collaboration can be divided into two stages with very different requirements. In the first stage, programming stage, the programmer or data consumer uses interactive programming interfaces such as Jupyter Notebook with smaller data and computation. At this stage, the data is hard to control, thus it poses higher privacy risk. In the second stage, execution stage, the programmer may submit their complete code, which will consume larger data set and computation. Since this should be only run once, it's easier to isolate execution and control the data. Thus, the privacy risk is lower. Based on this idea, we have designed a two-stage data clean room solution. In the programming stage, the platform allows data consumer to explore by providing interactive tools. To protect data privacy, the data provider can provision two different datasets depending on their needs. In the execution stage, the complete workload runs in an isolated and attestable DE instances, such that the data providers can manage data, code, and outputs based on the attestation report. There are three benefits of a two-stage data clean room with trusted execution environment. Firstly, data provider can decide a protection mechanism. At the programming stage, data provider can choose random data, differential private synthetic data, or public data. It can also do code output filtering at the execution stage, such as implementing cross-grant policy instead of per-query policy. Secondly, trusted execution environment provides transitions of trust in multi-way data collaboration settings. It can also provide integrity of code and output. The attestation report of trusted execution environment can be used as a proof of execution. At last, it can provide accurate results in the execution stage because of the full data access is securely enabled by trusted execution environment. To make it easy to deploy and use, we have built a platform on top of cloud's infrastructure. For example, we are using TE instances provided by cloud providers with the attestation services, key management service, and the storage service. We can easily deploy the platform. For the front end, we use Jupyter Notebook to provide a user-friendly interface which all data scientists are very familiar with. Next, let's talk about some different use cases of our Data Clean Room project. Firstly, our project can be used as a trusted research environment for research analysis. Providing transparency is an important responsibility of organizations, especially for large long-run and content platforms, as its data can be very valuable to many public domains, such as researches in public health, cultural trends, economic impact, and civic engagement. Trusted Research Environment, TRE, is one of the use cases of data collaboration, which provides a secure and isolated environment where authorized, vetted researchers and organizations can access the data. This provides as much transparency as possible to the research community. However, it is also important to respect the privacy of the data. Therefore, our Data Clean Room solution is a very good option. Data usability and privacy can be properly balanced. There are other potential use cases of the Data Clean Room in other domains. For example, in ads and marketing domains, Data Clean Room can be used for local-like segment analysis, ads measurement and conversion tracking. Also, Data Clean Room can be used for privacy-preserving machine learning. For example, it can be used for inferencing and training with private datasets, and inferencing and fine-tuning with private model. Then, let me show you the demo of the platform. In this demo, we will use a public dataset from Kaggle, a popular machine learning and data science community for data collaboration competition. We will show you how you can use our platform to train a machine learning model with the dataset using XGBoost regression algorithm. In the programming stage, to protect the data, we are applying differentially private synthetic data algorithm called MST, which is the 2018 NIST Synthetic Data Challenge winner. This provides better privacy protection. Here's the demo. As you can see, we provide the platform a Jupyter Notebook interface that the data science are very familiar with. First of all, you can install some dependencies used for data analytics. Then you can use our library to connect to the backend storage. Now you can explore the data and get some insights. Note that this is a programming stage, and what you see here is differentially private synthetic data. Basically, you can explore statistical distribution of the data, correlations. Once you have done with exploring the datasets, you can submit the data to the Data Clean Room, and it will build the image in the backend scheduled to the TE instance, executing the result in an SLA environment with stage 2 data. Once the job is done, you can basically download the output and check the result. With the insights of data exploration, next, let's build the XGBoost machine learning model. Similar with the previous example, we can install dependencies, program the model and parameters, and then submit the job. Now, you may be wondering, as a data collaborator, how do I know my code and data is protected by the trust execution environment? In our platform, we provide an attestation report as a proof. The attestation report is a JWT token. You can download and inspect the content of the token. You can see that here, the token is signed by the cloud provider and saying that this task is executed in the confidential space, which is one of the TE backend we are using. And you can compare the hash of the job with the one in the attestation report to make sure the job is faithfully executed in the trust execution environment. While building this data clean room, there are several lessons learned. Firstly, confidential computing is a very valuable tool, not only for security, but also for privacy. And confidentiality is only one aspect of confidential computing. It also offers integrity, attestation, and build trust with all participants as well. At last, using cloud-provided confidential computing solutions like confidential virtual machines can really help and accelerate to build these TE-based applications. Then let's see the current project status and the future roadmap. Currently, we only support one-way collaborations, and a single backend is supported in our platform, and the computation is with CPU. In future, we will consider support multi-way collaborations and bring in multiple backends, as well as CPU and the GPU computation. And we will also automate data provisioning and the policy and attestation process. At last, we just open sourced the platform. You can check out our repository at GitHub under the TikTok Privacy Innovation Organization. Since this is an open source project, now you can start experimenting and it may fit your data collaboration scenarios. In addition, you're very welcome to collaborate with us in an open way and contribute to the open source community. Okay, that's all about Data Clean Room project. Thanks for your time.